All right, hi folks, this is Larry Mussolino. I'm recording a video for Objective 7 in ALEX. And you could see Objective 7 is primarily solving rational equations. What that means is you want to be able to solve an equation that has rational functions in it, which means working with fractions. So let's take a look at a few examples here, and I'm going to go to some topics. Now, there's really going to be one common thread for solving these kinds of equations, and that is get rid of fractions as the first step. So here's the way we're going to work these out. Let me give you a general outline of how to solve these kinds of rational equations. Step one is going to be to get rid of fractions. Because if we could get rid of fractions, it's going to result in an equation that's much easier to solve. How do you do that? Well, the first thing you're going to do is find the LCD, the least common denominator. Then you're going to multiply both sides of the equation by that least common denominator. Now, this isn't normally what you do with a least common denominator. Usually a least common denominator is a way to add or subtract fractions. But we're taking this step because it turns out if you multiply both sides of an equation by an LCD, the fractions get canceled out. So this is a special procedure in order to get rid of fractions. So let's apply it to this example. It says here, solve for x. All right, well, let me look at the LCD here, the common denominator. Well, there's only one denominator here. It's x minus 7. So the least common denominator here is just x minus 7. So I'm going to take this equation that they're giving me, and I'm going to multiply both sides. So we found the LCD. Now I'm going to go ahead and multiply both sides of the equation by the LCD, which is x minus 7. So I'm multiplying both sides of this equation by x minus 7. All right, on the left-hand side, I have negative 7 multiplying this parenthesis. So I'm going to multiply inside using distributive property. This is going to be negative 7x plus 49. The reason I have a plus 49 is this negative 7 multiplies this negative 7, giving me a plus 49. But on the right-hand side, good news, this x minus 7 cancels out with that x minus 7, and so I end up with just 1 here. Well, now let me go ahead and subtract 49 from both sides of this equation. I want to solve for x now. I've gotten rid of the fractions. So it looks like I have negative 7x equals negative 48. Last step is to get x by itself. I'm going to divide both sides by negative 7. Cancels out. Looks like I'm ending up with x equals 48 over 7 as the solution. It does say simplify your answer, but this fraction 48 over 7 is simplified, so that's going to be the final answer for this one. All right. Now, one thing I do have to double check on these kinds of problems is I can't come up with a solution that would result in division by 0. Because remember, you're not allowed to divide by 0. In fact, if you tried the problem 15 divided by 0 on your calculator, you would get an error message, right? So you're not allowed to divide by 0. When I come up here to this original equation, I'm noticing I can't let x equal 7. Because if I let x equal 7, I would end up with a 0 in this denominator. So cannot have a solution of x equal to 7. But that's okay. My solution is not equal to x equals 7. It's x equal 48 over 7. So my solution is acceptable. Okay, but I do have to double check that I'm not coming up with an invalid solution that causes division by 0. All right, let me go and do a couple more. Let's take a look at this one. It's a little more complicated. But I'm really going to do the exact same thing. I want to solve an equation. I want to get rid of fractions. So I'm going to follow the steps. First step is going to be find the LCD. Then I'm going to multiply both sides of the equation by the LCD. That's going to let me get rid of fractions. All right, let me figure out the LCD. Well, I'm seeing the denominator is x minus 2 here and x minus 2 there. Well, that LCD then just must be x minus 2. So let me take this equation, the starting equation, and I'm going to multiply both sides by x minus 2. All right, now the only thing I got to be careful about is on this left-hand side, I'm really multiplying the whole equation by x minus 2. And of course, I have to do the same thing on the right side, multiplying that side by x minus 2. But on the left side, this x minus 2 actually gets distributed to multiply each one of these quantities inside the parentheses. So this is what I'm going to end up with. Do this in red. Okay. All right, well, on the right-hand side, I'm going to let this 5 multiply inside the parenthesis here. So that's going to be 5x minus 10. But here's the good news. On the left-hand side, this x minus 2 cancels out with that x minus 2. That leaves just 3x. And this x minus 2 cancels out with that x minus 2, just leaving a 2. So notice now I have a much nicer equation to solve with no fractions. All right, well, now I'm just going to get x's on the same side. Maybe I'll subtract 3x from both sides to get started on that. This cancels out. I'm left with negative 2. This is going to be 2x here, minus 10. I'll add 10 to both sides of this equation to finish this up. And then it looks like 2x equals 8. So x equals 4. Let me just do a quick double check. I'm noticing in these denominators, I cannot let x equal 2. Because if I let x equal 2, I'd be dividing by 0. So I can't come up with a solution of x equal 2. But that's okay, I'm not. I'm coming up with a solution x equal 4. And x equal 4 is a valid solution. By the way, you could double check your answer by plugging back into the original equation. Let me show you that very quickly if I wanted to, a quick double check. So this is a check of the answer that x equals 4. So I'm going to go back to the original equation and replace x with 4. So this is going to be 3 times 4 on top over 4 minus 2 minus 2 over 4 minus 2. Does that equal 5? Well, this is 12 over 2 minus 2 over 2. All right, well, 12 over 2 is 6. 2 over 2 is 1. So it looks like my answer does check out because I end up back to 5 equals 5. All right, always a good idea to check your solution if you would like, because that gives you confidence that you didn't make a mistake along the way. All right, let me go and look at 1 or 2 more. You might notice we're really doing the same kinds of analysis in each one of these. Okay, let's take a look at this one. This one's a little more complicated. Well, first, I'm going to find the LCD. So remember, step 1 here. I'll also show you the explanation as well. Maybe we can kind of follow along with the explanation. All right, so first let me find the LCD. Well, to find the LCD, I'm going to factor these denominators. So you might notice I could take 2u plus 12 and write it as 2 times u plus 6. Now let me find the common denominator. Well, here's what I'm noticing. For the numbers, I'm seeing a 2 in the denominator, and then I'm also seeing this parenthesis u plus 6. Over here is another denominator, u plus 6, but I already have that accounted for in the common denominator, so I'm not going to repeat it. So this is the least common denominator. So let me go ahead and take this equation. Here's the starting equation. And I'm going to multiply both sides of this equation by the least common denominator. So I'm going to multiply this side by 2 times u plus 6. And I'm going to multiply this side 2 times u plus 6. All right, let me do it. Now, on the left side, I got to be careful because I'm really multiplying this entire left side, which means I'm really going to be doing a distributive property here. Okay, so let me do it. I'm going to multiply 2u plus 6, and this is going to multiply. I'll do it in blue here just to be consistent. This is going to be multiplying -7 over 2u plus 6. Then I'm going to take that same 2 times u plus 6 and let it multiply the 1. Okay, and on the right-hand side, I'm noticing this u plus 6 cancels out with that u plus 6, so I just have -7 times 2, which is -14. All right, well, again, good news. This 2 cancels out with that 2. This u plus 6 cancels out with that u plus 6. Okay, so I'm left here with -7. I'm going to let this 2 multiply inside the parenthesis here. So that's going to be plus 2u plus 12. And on the right-hand side, I have -14. Okay, you can see we're at this step in the solution. By the way, you know, folks, I think these explanations are pretty nicely done because they really show you exactly what to do step by step. Now, the good news is I have an equation with no fractions in it. So let me combine. Here's a -7 plus 12. Well, that's 5. So I have 2u plus 5 equals -14. Now I'm going to subtract 5 from both sides. That cancels out. Get 2u equals -19. Last step, divide both sides by 2. Looks like I'm coming up with the answer u equals -19 over 2. Okay. And I know that's a valid solution. When I looked at the very starting equation, I noticed I cannot let u equal -6 because that would result in division by 0, but I'm in good shape because my answer doesn't look like u equal -6. So my answer here is valid. All right, let me do maybe 1 or 2 more. Again, I think you can see the process is find the LCD, looking at all the fractions in the equation, multiply both sides by that LCD. That should allow you to cancel out any fractions. All right, let's take a look at this example. And notice this is an example where we might end up with a quadratic equation to solve at the very end. So it says we might end up with a quadratic equation. All right, but let's follow the same steps. Step 1 is find the LCD. Step 2 is multiply both sides by the LCD. All right, so let me look at the fractions here. Well, I'm seeing a u and a u, so I know the LCD is just u. All right, so what I'm going to do then is let me take the starting equation. Here it is. I know the LCD is u, so I'm going to multiply both sides by that quantity. So I'm going to multiply this side by u, and I'll multiply this side by u also. Notice the way I put the u outside the parentheses. Now this u is going to multiply inside. So it's going to be u times u plus u times 7u. On the right-hand side, notice the u's cancel out. So I end up with just a 32. All right, let me keep going. Here's a u times u. Well, that's u squared. This u cancels out with that u. So that's just going to be a 7. And that's equal to 32. All right, I'm almost done. I'm going to go ahead and subtract 7 from both sides. Looks like I'm ending up with u squared equals 25. Okay, now I want to try to solve this equation. There's a couple of ways I can solve this. Maybe one way I could solve it is, you know, with quadratic equations, it's a good idea to get the equation set equal to 0. So I'm going to subtract 25 from both sides. That's going to get me u squared minus 25 equals 0. On the left side, I can factor this as the difference of two squares. Then once you do the factoring, you might remember you set each one of these factors separately equal to 0. So that's u plus 5 equals 0 and u minus 5 equals 0. And that's going to get me, I'll subtract 5 from both sides here. That gets me u equals negative 5, and I'm going to add 5 to both sides here. That's going to get me u equals positive 5. And I think those are both valid solutions because notice in the original equation, I cannot let u equal 0. If I let u equal 0, I'd be dividing by 0, but both my answers are not 0. So both my answers here should be valid solutions. And I could check my answers by plugging those solutions separately back in the starting equation, confirm they lead me to a true equation. All right, let me do maybe one more example here. All right, let's take a look at this one. This one's a little more complicated, but I'm going to follow the same procedure. I'm going to find the least common denominator. So step 1 is going to be find the LCD. Step 2 is going to be multiply both sides of the equation by the LCD to get rid of fractions. All right, now before I find the LCD, let me do a little factoring here. So let me write this as 2 parentheses, and I know I'm going to put a y and a y in front. I need 2 numbers to multiply to 10, but add to negative 7. Well, it looks like that's going to be y minus 2, y minus 5. And then on the right-hand side, I have 1 over y minus 5 plus 4 times y minus 2. All right, so let's find the LCD. To find the LCD, you might remember this from the last objective. What you do is you look at these denominators and write down the multiplication of all the unique factors. So I'm seeing a y minus 2. That's got to be part of the LCD. I'm seeing a y minus 5. That has to be part of the LCD. Here's another y minus 5, but I'm not going to repeat it because I already have this y minus 5. And here's a y minus 2. I'm not going to repeat that. I already have y minus 2. So the LCD here is y minus 2 times y minus 5. All right, I'm going to multiply both sides of the equation by this LCD. All right, let me do it. On this side, I'm going to multiply this by y minus 2, y minus 5. And I'm going to do the same thing on this side, multiply this by y minus 2, y minus 5. All right, so let's do it. Well, on the left side, the good news, this y minus 2 cancels out with that one, y minus 2. This y minus 5 cancels out. I'm left with just a 3 on this left side. All right, on the right-hand side, I got to be careful because this red y minus 2, y minus 5 has to really multiply inside as like a distributive property. So I'm going to write that all out. So I have a y minus 2 times y minus 5, and that's going to be multiplying this 1 over y minus 5. Then I'm going to have again that y minus 2, y minus 5. And that's going to be multiplying the second fraction in the parentheses, the 4 over y minus 2. Okay, so again, this was a kind of a distributive property. All right, well, let's clean this up. I'm noticing this y minus 5 cancels out with that y minus 5. So that's just going to leave me a y minus 2 multiplying 1. So that's just y minus 2. Back here, this y minus 2 cancels out with that y minus 2. So I'm going to have a 4 times y minus 5 back here. Okay. All right, well, let me take this 4 multiplying the y and this 4 multiplying the 5. So it looks like I have 3 equals y minus 2 plus 4y minus 20. Well, again, this is a nice equation for me to solve because there's no more fractions. All right, so let me combine like terms. Here's a y and a 4y. So that's 5y. And then I have a -2 and a -20. That's -22. All right, I'm going to add 22 to both sides. I want to get y by itself. So that'll cancel out here. Looks like I'm ending up with 5y equals 25. I'm going to divide both sides by 5. That cancels out. Looks like I'm ending up with y equals 5 as my answer. But remember, I got to be careful because I got to check if that's really a valid solution. Well, when I go back to the starting denominators, notice I have a y minus 5 and a y minus 2. Well, that tells me I cannot let y equal 5, and also I cannot let y equal 2. Because if I do, that would result in division by 0. So my answer of y equals 5 is actually not valid. Because if I plug in y equal 5 back in the starting equation, I'll end up with division by 0, which is not allowed. So it turns out for this example, it's a little tricky, but there's no solution. We came up with this possible answer of y equal 5, but we had to know that that wasn't allowed as a solution because it would result in division by 0. So that means we cannot use y equal 5, which takes us to a no solution result. Okay? And when you go to do this in ALEKS, there will be an option for you to pick from that says no solution. Okay? All right, folks, hope this is helpful as you're working in Objective 7. Please let me know if there's any questions.